Okay, we're going to determine the absolute minimum. So this question says light intensity, so our IIT is measured by this function here in terms of time. And the time is measured in seconds, t is seconds. And it's within the interval of 0 to 14 seconds. They want us to find the absolute minimum intensity of light between 0 and 14 seconds. Now, because we have a rational function here, okay, technically we have to be careful. We need to find out if this becomes an undetermined equation. Well, luckily, the only way this becomes undetermined if t is at -2, and because -2 does not fall within our interval, we're going to be okay there. Okay, we don't need to worry about rationalizing this, or changing it around. So, to find an absolute minimum and maximum, we know we got to deal with our initial and ending point, 0 and 14. We're going to plug those in eventually. We also got to deal with any turning points along this function. To find the turning points in the function, or when the tangent to the line is horizontal, we got to derive. So the derivative of this is where we're going to use our quotient function, where we derive f at x. And if you don't remember how to do it, you're going to have to go back and look. I'm not going to write it up here this time. F at x, we find the derivative of the top. Well, derivative of the top is 2x plus 2 times the original at the bottom, so that's t plus 2. Subtract the original at the top, t squared plus 2t plus 16. Times the derivative of the bottom. The derivative of the bottom is just 1, and this is all over the original bottom squared, which is t plus 2 squared. Okay. What we're going to do from here is we're going to simplify the top of this equation. The reason we're going to simplify this is, remember, we're trying to find when the slope is equal to 0. If I were to plug 0 in for the derivative right now, and I'd have to set this equal to 0, it becomes very complex. So I'm going to try to simplify it, specifically the top of the equation. Okay. We're going to use our FOIL here. 2t times t gives me 2t squared. 2t times 2 gives me 4t. 2 times t is 2t plus 4. And because that's times 1, nothing changes except that there's a negative in front of it, so we subtract all these terms. T squared minus 2t minus 6t. All above. All aboard. T plus 2 squared. Okay, well, let's collect our like terms. We have 2t squared, negative t squared. That's going to give us t squared. Okay. We also have 4t, 2t, and negative 2t. That's going to give us 4t. And finally, we have 4 and negative 16. That's going to give me negative 12. So this is the simplified version. T plus 2 squared. We may even be able to factor this and factor out one of these t plus 2's at the bottom, but we'll leave it for now. Remember, our goal is to find out when this is 0. Well, now that I've simplified this, if I set this equal to 0, the only way this fraction becomes 0 is if the top of this is equal to 0. We're not worried about the bottom. Remember, it doesn't fall in that interval. So, I now can split this equation. I don't really need to deal with the denominator of this fraction. I just set the top equal to 0 because we need to know when this is equal to 0. And this is where we go factoring again. Okay, when we factor, because this is the term 1, this is really easy. Two things to multiply here, add to here. So we're going to get t and t. Multiply the 12, add the 4, 6 and 2. Positive 6, negative 2 is equal to 0. So we get t is equal to negative 6 and t is equal to 2. Well, negative 6 did not fall in our time interval between 0 and 14, but 2 did. So we're going to take our original equation, the light intensity, and we got to solve when t is 0, 2, and 14. These are our initial values. We'll call them A and B. And then our turning point 2. We're going to plug them in. I'm going to tell you that when you use I at 0, so we plug it into the whole equation. You want to see it? I guess we might as well. The original equation was t squared, so we get 0 squared plus 2 times t, which is now 0, plus 16, all divided by t plus 2. Well, that's 0 plus 2 in this case. This is going to give us 0, 0, 16 over 2. Exactly. 16 over 2 equals 8. I at 2, same idea. 2 squared plus 2 times 2 plus 16 divided by 2 plus 2. Let's talk about what this is going to give us. This will give me 4 plus 4 plus 16 is 24. This gives me 4, 6. And finally, I 14. Will not be as easy to calculate. 2 times 14, all divided by 2 plus 14. I'm just going to, instead of solving that, I'm going to tell you what it is. The answer is 15 in intensity. So, let's think back. What the heck was the original goal here? Well, they asked us for minimum light intensity. Minimum light intensity occurs at our turning point of 2 when the intensity is 6. Okay? So that is our final answer.